Hey everybody, this is Guardsman, and we're back with another modding tip of the day, or just tip of the day in general. I've kind of realized that when making these, I am using the modding tip of the day, but the reality is a lot of these tips will apply to just about anything and everything, at least some of the ones I'm doing currently. In the future, this probably will change. I'll start doing more specific to modding ones, or I'll mix it up. I'll probably do a little bit of everything. But for the modding tip that we're going to do today is keep it simple. Now, don't get confused when I say this that I actually mean make simple content or do simple things or everything else. But it goes under the principle of keep it stupid simple, and it applies more to the implementation of the code than it does to the design of what you're doing, although doing it on the design too can save you so much trouble. But the principle, the concept behind it is when you're doing something, try to take whatever you're doing and break it down into simple steps and keep each step really simple. So say, for example, like the analogy that I end up actually using in here is building a house. When you build a house, you are essentially doing a lot of simple steps to actually get the house built. A lot of people who are unexperienced with building anything will try to jump to what they perceive to be the easiest step possible, but will end up overcomplicating it or doing something like that is really, really hard and was completely unnecessary. If you watch somebody build a house, how they go about doing it is first one, they lay the foundation. So they usually either dig a hole for a basement or they just lay a big concrete pad. My house, for example, I live in is a big concrete pad. Then when they get that done, they do a little bit of other things like lay pipes and stuff out. But when they start building the walls, they don't like nail some boards into the ground and then put some boards on those and stuff, everything else. They build a side of a wall and they start by simply nailing pieces of wood together. So you get different pieces of wood and they nail those together. They get a frame. I think it's actually called framing is what the terminology is for it. But they'll build a wall section, then they'll lift it up, then they'll put it in place, and they'll build a few more wall sections, and they'll rinse and repeat this process. Then they'll start putting supports into the walls and fixing stuff up, doing the window frames and anything they needed to do that they didn't get in the first step. But what they did is they did really simple steps. They started with nailing boards together. Then they lifted the wall up. Then they did the next step, and so on and so on. The reason for saying keep something simple is this applies to kind of what I'm going to apply it to the code itself. Is a lot of people try to build really complicated code. They go, okay, I'm going to be really intelligent. I'm going to build a really elaborate system that's going to do this thing and so on and so on. And that's all cool and everything. It's a really cool way to learn, but when you're making an actual product or you're making something you want to get done, you want to start with simple steps. Like say I'm making a block. The first step I want to do, I want to make the mod first. I want to get the mod class up. I want to get my registries running. I want to make sure I have all the events I need to get the block registered and get all its content registered. Even before I do that, I want to make sure the folder structure is up. And before I do that, I want to get the GitHub structure up. And each of these steps, you keep it simple. Like you go, okay, step 1, get GitHub repository made. Step 2, clone it. Step 3, make sure the folder's in the right spot. Step 4, get the folders in there. Step 5, make sure your build scripts are there, and so on and so on. And they're really simple steps. Rather than saying get all the initial files ready, because what does that mean? What are the initial files? I break it all down into very simple steps that are easy to repeat, easy to do, not too hard to think about, not too hard to execute, and you get each step done and you can check it off of a list and keep going. So you get all that stuff, but going back to the example, so you get the mod class registry, everything, and you get the block. You make the block class first, and a lot of people, well, I wouldn't say a lot, because a lot just feels like a weird way to say this. I've watched people do this, where they're going to make a block, and they'll go, okay, I'm going to do all my rendering, I'm going to do all my texturing, and then I'm going to figure out how to attach it to the block, and they've forgotten the core aspect of it. You didn't make the block class yet. You didn't put the logic in the block class, so your block doesn't do anything. It's cool to make it render and everything, but you didn't do anything with it. So when you make a block, you first want to start and make the block class. Get your basic properties in there. Like, just keep it simple. Like, get some simple properties in there, make sure it doesn't break instantly, make sure the player can pick it up and place it, and make sure that if you had some interaction with it, the interaction works. Get your inventories up if you had an inventory on it. Get some power going and then go to the next step and so on and so on. Keep really simple steps. And I'm kind of starting to realize that this is divulging into kind of a best practice type of thing, which don't get me wrong, I'm using just a random example. It doesn't matter what the step order is as long as you keep it simple and try not to overcomplicate it. But another example that might be a little better is I actually watch people do this with pipes and power code a lot of times. They're like, I absolutely have to have a network system for my pipes, or I absolutely have to do this really complicated tick system, or I have to make it threaded. Very often, what you want to start with when making pipes and wires, build a really simplistic system. Get the wires to connect to each other, and get the wires to transfer power to each other. It's really simple. It's not the most performant system in the world, but you get a prototype going and it works, and you can test your code and test your logic, and then you can build from there. You can go, okay, I want to do the power transfer via network object. Okay, make the network object. Get the network object connecting to all the wires first. Don't make a really elaborate system where you keep track of like the sources and the outputs and the load and the channeling through the power and all that stuff, because if you go ahead and get all that stuff in there, you're going to produce a ton of complicated interworking and interlocking segments of code that when you need to debug, you're not going to be able to debug because you can't test individual parts. This also relays a little bit into the implementation. When you're writing code, build really simple blocks of code. If you make a big method and that method has a lot of parts going on it, say I need to track all of my connections around me. I then need to take those connections and filter them down to fluid tanks. But at the same time, I also need to filter the energy tanks. And then I need to separate those into 2 different lists. And then once I get those lists separated, I then need to output power to the power systems, input fluid from the fluid tanks, and then I have a processing step and everything else. So you see, as I'm saying this, you might be getting lost in what I'm saying. It's because that actually does start to sound complicated, but the reality is there's a lot of simple steps going there. So your first simple step, collect all the tiles around you. Okay, that's a method now. You don't even make that as a segment of code inside your previous method. You make a method called collect tiles, and then that returns a list of tiles. Then you go to your next method and go, okay, get me the fluid tanks out of this. That's now a method as well. You pass in the previous list and it brings you the list of fluid tanks. Then you get this identical method for your energy tanks, the stuff that needs to store energy. You now have 2 separate methods for that. Really simple methods, easy to debug, do a single purpose, very simple task, not very complicated. And you keep rinsing and repeating this over and over again, and what you end up doing is you create a lot of very simplified mechanics and systems that do a single purpose, that are not complicated or not made incredibly elaborate to save you a little bit of code and time. They're really easy to debug, really easy to unit, and they actually will end up becoming more and more reusable as you go. Some examples of this I can even actually give is some of the code I'm working on for atomic science and actually doing it. I have a processing machine prefab that I use by on my processing machine, and it has really simple methods in here. It goes, okay, is the empty fluid container? It goes, okay, I gotta get my stack. Stack's another simple method that just grabs the inventory for me. I then check if it's null. I then check if it's a fluid container. I check if it's an empty container, and so on and so on. And I just repeat these steps. And there's tons of methods like this. You can go through here and you'll find a lot of really simple methods, like add to output has input space. And they're simplified methods that don't do anything complicated. They're really simplified, really easy to use, and in a coincidence of just how they were built, they actually are incredibly reusable. I can take this method and drag it to another machine, assuming that the other machine also had access to the power system, because the power system also has reusable code in it that's really simplified and easy to use. But doing this actually will save you tons of time and keeps it simple. And then a way to think about this in terms of not just a code, and your design itself. Say you take a design and you start working on the design and say, okay, I want to clone Applied Energistics. Applied Energistics at face value is a complicated mod. But what you can do is build really simplified mechanics in your design. You can go, okay, I need to build a storage network. The storage network needs to have drives, it needs to have cables, it needs to have some kind of control center that everything connects to. The cables need to have a limiting on how much they can do data-wise and everything else. And you start putting it out in your design, you start realizing it's really, really complicated, but then you can take each step and you can break it down. So I have a drive. What does a drive do? Well, it has an inventory, so you make that a step. I need to make a block with an inventory. You add another step. I need to make a block. So you go first step, make the block. Second step, make the inventory. Third step, make the inventory allow only drives in it. Fourth step, allow access to the drives, so you can actually get to the drives. Fifth step, add cable connections, and so on and so on. You really simple steps, really simple mechanics. And by doing so, you actually make your design easier to understand, easier to work with, and then when you go to the implementation, you have simplified mechanics to implement. Atomic Science is another really good example of this. So Atomic Science is built 100% behind the principle of simple mechanics. Every single thing in here has a single purpose to do a single task. I mean, some of the machines do have overlap, but that's not the point. what we do is we build everything to just do its thing. There is no complexity to it and everything else. So each of these machines is a processing machine. Processing machine has inputs, has outputs. This happens to have 2 inputs, a fluid tank and a slot, and 3 outputs, so 2 fluid tanks and another output slot. Simplified mechanics. You put items in it, you get items out and fluids out. All the machines are identical to this. Extractor is the same way. Inputs, outputs. And then centrifuge if we can find one. Same process. But the processing machines are not the only example of this. The reactors themselves are built behind this concept as well. So some people, what they'll do is when they design really complicated machines is they'll build big multi-block structures that have a ton of parts going into them that you have to put into certain orders and you have to do certain things. But what you can do is you can build something like this. The reactor, for all intents and purposes, is a block that has an inventory that runs a very simple process that outputs radiation and outputs heat. Simple processes. This outputs heat, doesn't know what blocks are around it, doesn't care what blocks are around it. Outputs radiation, same process, doesn't know what's around it, doesn't care what's around it. These mechanics are fed into other simple mechanics that generate the heat. So this will make heat, spread it around the area. That's a really simple mechanic of spreading heat. That then will work with another mechanic of boiling off the water or melting blocks or transferring heat between different blocks and so on and so on. But it's a simplified block with a single purpose and single design. And then it just so happens that when you stack these on top of each other, they have another simplified mechanic that changes the way they render, and so on and so on. And then they have other things that work together with each other. Turbines are built the same way, simplified mechanic. They just detect how much steam is produced. Based on the number they produce, they have another mechanic of outputting power. And pretty much every block's designed this way. But it's a really interesting way to design things, is you don't end up with complicated systems. But the beauty of it is you can take a whole bunch of simplified mechanics and make it look like a complicated system. Someone looks at this reactor, sees the reactor all put together and goes, that must be a really complicated thing. You have water being steamed off. Let's actually get some reactor cores here to show this. So you have a reactor that's producing a lot of heat. These are actually dead rows. Producing a lot of heat that's causing water to boil off, that's causing steam to generate, that's causing turbines to spin, and they're like, oh, there must be tons of stuff in here. This reactor must detect all the blocks around it. It must have to detect this entire environment. It must do a ton of mathematical calculations. It must then have to figure out how to calculate where the turbines are and then relay the power to the turbines. And all these complicated stuff is what somebody would see, but the reality is there's a ton of really simplified processes that link together to build a system that looks complicated. And for those who actually want to do more reading on this, go look up system theory, because it's basically what I've been describing the entire time. Anyways, I'll leave you guys here and I'll be back with the next video.